one. Before I go for this one, this one, SPSS, let me show you the last part of the testing. Before and after, if you want to see whether the coaching is beneficial to the student or not, or you want to see whether a particular advertisement increase the sale or not, whether a particular coaching is effective or not, or whether a particular advertisement is effective or not, before and after case. In the case of before and after case, you can apply this pair sample t-test. The formula was d bar divided by AC. This is mean of the difference. Before the coaching, whatever the student score mean, then after the coaching, whatever the score, mean score, you just minus it, and it is called D minus, means of the difference. Then AC, as usual, AC is standard deviation by root over n. Then after the calculation of AC, you put here, then you got the t-test. Now you got this. To verify whether a coaching in statistics improved performance, a similar test was given to 12 participants before and after. The original marks recorded in alphabetical order of the participants were given below. Test whether the coaching was useful. Now your hypothesis will be coaching was not useful. Then your alternate hypothesis may be coaching was useful. The performance was not different. The performance of the student before and after, there is no difference. That means coaching was not useful. The performance of the student after the coaching is not different from the performance of the student before the coaching. Not different means what? Not different means coaching was not useful. So under that circumstances, you can apply this related t-test. Now, how about this? There is no significant difference in the mean score of the performance of the participant before and after the coaching. There is significant difference in the mean score of the performance of the participant before and after the coaching, alpha 5%. Why t-testing? This is a case of before and after, and data are metric data. Decision rule, table value of t for the degree of freedom. Here you are having related sample. The same sample you are using. The same sample before, number of students, the same number of students before, you have taken some tests. The same number of students after coaching, you are making tests. So your sample, you will consider it as the same sample. So n minus 1, 12 minus 1 is the degree of freedom, 11. So you refer to the table. The table value is 2.201. If the calculated value of t is less than 2.201, implies that S node is accepted. If the calculated value of t is greater than 2.201, then implies that null hypothesis is rejected and S1 accepted. Now we calculate it before and after the coaching, before the course, after. So these are marks scored by Mr. A scored 44 before and got 53 after the coaching. Mr. B scored 40 marks before the coaching, and after the coaching he or she got 38. So difference 53 minus 44 is 9. 38 minus 40 is minus 2. 69 minus 61 is 8. So this is the difference. Then this difference, you sum of this difference, then this is the difference, and then you find the mean of the difference. Mean of the difference is 5. Then d minus dds. So this is the calculation. This is the variable minus difference. So similar to your calculation of standard deviation. So what about in your formula require d minus d bar. So in the table we have d minus d bar. Your formula requires d minus d bar. So accordingly we make d. This is the difference after minus before. So we have a column for d bar. Then we have a column for d minus d bar and square. Ultimately you got summation of d minus d bar whole square. Now your formula is standard deviation of the difference is root over d minus d bar whole square by n minus 1. You substitute, find AC, substitute here 5 by, so your t value is 3.472. So you compare this with the table value. Since the calculated value of t is greater than 2.201, table value implies that S0 is rejected and S1 is accepted. There is there is significant difference in the mean score of the performance of the participant before and after coaching. But statistics doesn't say which one is better. Simply says that the mean score after and the mean score before, there is a difference. Then you observe. By observation, we found that further, see, statistics doesn't say which one is effective. But simply this testing says that there is a difference between the mean score, further by observation. Further, the mean score of the performance before the coaching is 54, which is significantly lower than the mean score after the coaching, where the mean score of the performance is 59. Therefore, it can be said that coaching was useful. Statistics doesn't say which one is better, but it simply says there is no difference or there is difference. They say there is difference, then you come to the table by observation. The mean score before the coaching is this much, 54. Mean score after the coaching is 59. So average score is more. So coaching is effective. And this can be applied in this case also. See, these ladies, they all make they always make a surgery of their face. Before the surgery, they look like this. After the surgery, they look like this. Whether the facial that changes were effective or not. A beautician claimed that he can bring around the remarkable change in the face of the people who come to him to make over, for a makeover. To test these, 10 people were considered. They were judged by the expert before the makeover and again after the makeover in 10-point scale. And this is the score. Is the improvement significant? If there is any improvement in the facial that makeover, then is there any improvement? So we have to say there is no significant difference. There is no significant difference before and after. The same t-test can be applied before the operation, after the operation, before the facial makeover, after the facial makeover. Is there any significant change or not? So this can be done by testing. Then last one, this one. The conclusion is that since the t value is less than the table value, calculated t is less than table value at 5% level of significance. So we accept the null hypothesis and state that the makeover does not have any significant impact on the improvement in the facial beauty. So this is the way we have calculated manually. Now I have engrossed upon the time of demologos, but I will show you how SP is being done. There's one sample test. There's one sample test that we have done manually. Now let us do it. First, this is the data. First, let us check whether this data is normally distributed or not. So, is it visible? Divisuti, my spaces?
Visible.
Yes, sir.
Visible, sir.
Now, this data, you have to check whether it's normally distributed or not. Go to analyze. Go to descriptive statistics. Go to analyze. Then go to descriptive statistics. Then go to explore. Then the life of the bulb. Put here. We want to see whether it is normally distributed or not. So normality plot is here. If you want to go for histogram, you can go for histogram. But since the sample size is very less, we will not go for the histogram. Now, after this, let me go once again. Descriptive statistics. आ गया. Sorry, why is slow? No, please note down this one. Excuseness statistics. 0.625. Please note down. Devo, please note down. 0.625 statistics. Excuseness 0.625. Standard error 0.845. So please note down this one. Excuseness 0.625. Now you divide it by 0.845. How much it comes? The kurtosis is, please divide minus 0.750 by 1.741. Excuseness 0.625 divided by 0.845. How much it comes? Divo? Dipjuti,
Sir,
are you
it
there?
comes 0.739.
Point,
7396.
and then kurtosis minus 0.750 by 1.741. How much?
1 second, sir. 1 second.
Minus 0.750 by 1.741.
It's minus 0.431.
0.431. Now, so these two values lies between plus minus 1.96. Okay. This 0.739 lies between plus minus 1.96, and then minus 0.431 also lies between plus minus 1.96. They lie in the range from minus 1.96 to the plus of 1.96. So they lie somewhere between minus 1.96 to plus 1.96. So your data was normal. Or since sample size is less than 50, you look here, Sapiro value is 0.933, and then your 0.6 is greater than 0.5. Sapiro value 0.933, and its p value is 0.6 greater than 0.5. So normal. Your data is normal. So far we check. You see, these are, since sample size is data, as I told you, sample size less than 50, you have to go by this. Is it visible?
Not
Divo?
yet. Not, sir.
No visible.
Not visible, sir.
Wait.
No, sir.
Slide visible?
Yeah, visible, sir.
Yes, sir. Yes, sir.
No, just now we have done. I told you to write down 0.625 and 0.845, and you have divided. Then kurtosis minus 0.750. I told you to write down. So when you divide 0.625 divided by 845, you get jet skewness 0.7396. And kurtosis, when you divide this value by standard error, you got this one. So both the values are lies between minus 0.96 to this value lies between minus plus 1.9. So normal. Now you go through Sapiro. Sapiro value was 0.33, P value was 0.6. So P is greater than 0.05. So data is normal. I've shown you this one. Do you remember this one? If your sample size is less than 50, then P value should be greater than 0.05, and the standard value should be plus minus 1.96. So this indicates that our data were normal. So data was normal. Now we are ready for testing the hypothesis to compare the mean of the population and the mean of the same, or to verify whether the claim of a manufacturer of a certain megawatt electric bulb, that is bulb have a mean life of 25 months, is valid. So the same procedure we follow. Now let us test. So this is the life of the bulb that we have given. So it is normally distributed. Now analyze. Go to compare mean. One sample. Compare mean. One sample. Life of the bulb. This test variable. Then claim was how many? 25. Claim was 25. This is for one sample. Now you go through it now. Analysis. So one sample statistics. So here 0.3 p value is 0.328. P value is minus 1.085, but your p value is 0.328. P value is 0.328. 0.328. Now now you write down now. Normally after the we write down like this. The objective was to compare the comparison of the mean of the population and the mean of the sample. The objective was to compare the mean of the population and the mean of the sample. The data were analyzed with the help of t-test, and the results are given in the table number 1. So life of the bulb, mean, standard deviation, number of sample, population. This is given here. So mean of the sample, mean of population, standard deviation, and p value. So here p is greater than p, the 0.25 from analysis is greater than 0.05. So p is greater than 0.05. So there is no significant difference. There is no significant difference. So interpretation, it can be seen that the p value is this, which is not significant at 0.05 level of significant with degree of freedom 5. It means that the means of the population and the mean of the sample do not differ significantly. Thus, the null hypothesis is that there is no significant difference in the mean of the population and the sample is not rejected. Therefore, the producers claim that his bulb have a mean life of, this is valid. So nowadays, earlier we used to calculate manually. Now it can be done with the help of SPSS in one click away, if you know how to enter the data. Now, the independent sample t-test also can be done. Drug A, drug B also can be done. After testing the normality, here it found normal. Then you can go for testing p value. So what we have calculated, you can do it. You can do it with the SPSS. No, but just one click away. Now I will, at this juncture, I would like to say one thing. There is ANOVA will take another 1 hour for the one who goes. So let me conclude. Before concluding, let me tell you. Now what happened? You have spent 4 years in collecting the data. Finally, you found that your data is not normal. While framing the questionnaire, you frame the question in such a way that you'll be using t-testing of independent sample. Whether like this, mean preference. Oh, well, the anxieties of the teachers of anxieties of the teachers of Guwahati and anxieties of teachers of Silchar. You want to see whether there is any significant difference or not. The anxiety level of teachers of Guwahati side and Silchar side, whether there is any significant difference or not. You want to see it. So with that intention, with that motive, you frame the questionnaire. Data is there, but when you run for the data, there is no normal. There was no normal distribution. Then what to do? 4 years you have spent collecting the data in your PhD. Now your data do not exhibit normal distribution. Then what can be done? Okay, so one sample t-test that you wanted to use now, because of your data is not normal distribution, you can't use it. Go for one sample recognition sign rank test. Now you wanted to compare the mean anxiety level between Guwahati and Silchar, but your data is not normal. Go for Man-Whitney test. Don't drop the data. Alternative is there. Man-Whitney test. because for non-parametric, there is no need for normal distribution. Now you wanted to use pair sample t-test, collected the data, but data is not normal. Don't worry, go for pair sample Wilcoxon test. But still, if you want to adjust the data, still you wanted to see some adjustment in the data to go for parametric, then there is a way. If you don't want to go for non-parametric, again, still there is a way. Now, some sort of, this is not the manipulation. This is some sort of adjustment with the data. Because my data is not normal, so you have to check the skewness, kurtosis, whatever. Then some adjustment can be done. Their manipulation means some adjustment can be done so that your data can be look like normal. One is vinsorization, where the one method is there, vinsorization, then this data trimming, this data dropping. And another is data transformation. If it is positively skewed, the formula for transportation is log 10x. And if your data is positively skewed and variance heterogeneity, then you can transform your data with the help of root over x. And then if it is positively skewed, variance heterogeneity, if this is the case, then you can transform your data with the formula 1 by x. So even if your data is not normal, you can adjust your data so that it can be bring nearer to normal, or otherwise you go for this non-parametric equivalent. So earlier we used to calculate manually. Nowadays, if you know the basic concept, then you can easily use SPSS for t-testing, ANOVA testing, and then for chi-square, and for many correlation regression you can use it. So since time is running out, and another portion ANOVA is left, and we have requested Dr. Malugos, who is expert in ANOVA, to discuss with you. So I wanted to cover chi-square today, but today it is not possible. The same thing, if you know the condition, chi-square can be applied when the data are nominally scaled. I will show you something. What do you want? Give me 2 minutes. Dr. Devo, is it visible?
Visible, sir.
Non-parametric.
Visible, sir.
Visible, sir.
So, see, non-parametric statistics, if you want to go for chi-square, these are all non-parametric statistics. Non-parametric statistics, suppose non-parametric data statistics are it depends upon data. Data can be nominal or ordinal. If the data is ordinal data, then you have to apply Kolmogorov details. But if the data is nominal, then either you can go for one sample chi-square goodness test, and 2 sample you have to go for independent contingency test. Or if it is dependent, whether the two samples are related or not, then you have to go for McNamara test. This is the flow chart. So it depends upon your condition. So in order to apply chi-square, your data should be nominal data. If you want to apply Kolmogorov, the data should be ordinal data. Then within the nominal data, if it is 1 sample, go for chi-square goodness of fit test. But if it is 2 sample, again, 2 sample can be independent or dependent. If it is independent, go for chi-square contingency. If it is 2 samples are dependent, go for McNamara. So non-parametric statistics. So this one, these are the conditions. If the conditions are being fulfilled, data are nominally scaled, And if your intention is to test the significant difference within observed and expected, then you go for chi-square. Then you have to go for. So we have to check whether the conditions are being fulfilled or not. Whether my data fulfills the conditions or not. If not, then don't go for a particular. So for applying the chi-square, your cell data should be more than this cell data should be more than 5. In some cases, you'll find that cell data are less than 5, and people apply chi-square wrong. For the condition for applying chi-square is that every cell should have data more than 5, and the total number of items should be more than 50. So chi-square has certain condition, t-test has certain condition, ANOVA has certain condition. After knowing the condition, and if your data fulfills, and if your objective is required to go for that, then only you have to go for testing. So every tool has some requirement. Chi-square has certain condition for application, and when conditions are not being fulfilled, you can't apply it. Your thesis will be returned back to modify later on. I'm talking about some research scholars. Some research scholars might be there. So every tools and technique that we are going to apply has a condition, whether my data fulfills the condition or not. Only then you apply it. So thank you very much, Dipjyoti. I have enclosed some more time for Dr. Demalo Ghosh. So,
Sir, can you take 1 or 2 questions?
Yeah, please. Not many because Dr. Demalo Ghosh is waiting.
Yeah. If anybody has any questions, please ask, unmute and ask. Sir, I think the concept is so clear that
I don't know. See, since it is an online, and again sometimes there is signal problem also, and again we have to complete something within a stipulated time. So sometimes we have to run very fast. So
okay.
Any query that we are having on email later on when you are doing for PhD or when you are doing some research or analysis for any articles or PhD, please do send to us. Our email will be available through Dr. Dipjyoti Chaudhary, our important coordinator, and one of the beloved, our colleague. He has organized many programs for our department. So now over to Demalo Ghosh. So Dipjyoti, please.
Yes, sir. So we are having the second part of the first session, and we are with us having Dr. D. Ghosh. He's already introduced to us, so I think we further don't need any introduction. So straightway, can we go to the session, sir?
Thank you very much, Dr. Dipjyoti. First of all, am I audible to all of you?
Perfect, sir.
Yeah. With due permission from our honorable head of the department, sir. So, sir, we are starting the session since you have, completed your part. So, if you give me permission, so I am starting the session. Dr. Dipjyoti is there, and
Now you are expert. Now the floor is yours.
Sir, thank you
for encroaching the time. Thank you very much. Please,
thank you, sir. Thank you, sir. And our esteemed participants from all over India and from abroad, and our esteemed colleagues from Vidyasagar University and Assam University. So we would like to start the session today with the topic of ANOVA, analysis of variance. So yesterday we have completed or rather discussed the measure of central tendencies and all these measures of variations like descriptive statistics and distribution and all. So today's class I would like to straightforward or just going towards the ANOVA. So I have got the detail the sequence of discussion points, and after that I will try to initiate with this with the help of the software. So let me begin the analysis of variance. And in the analysis of variance, I would like to start the session with an example. The example is that basically, we have seen in case of particular factory when different operations are going on, and I would like to share the screen, and on the screen I would like to show you an instance. Here I would like to use the board, and in this board I think board is visible to all of us. Yeah, whiteboard is visible to all of us. And I would like to start the session with an example which I will try to explain during the course of the session. The example is that there are 3 brands of a product, and basically these 4 brands of electric bulbs, and the brand A, brand B, brand B, brand C, and brand D. These are the 4 brands of electric bulbs. And suppose we want to test the lifetime of 3 electric bulbs of each of the 4 brands, and there are 3 electric bulb from each of the 4 brands, and here we would like to have the data with us, that is 20, 19, 21, and here it is 25, and then 23, and then 21. So these are the sum of the values, and in addition to that we have some more values from the brand C, that is 24, then we have 20, and then we have hello, then we have 22. Am I audible? Hello? Hello.
Yes,
Yes,
sir.
sir, you are audible.
Yeah.
Yes,
So
sir,
that
yes, sir.
then 23, then 20, and then 20. So basically these are the 4 different brands of electric bulb. So brand A, brand B, brand C, and brand D. Suppose we are testing the lifetime of 3 electric bulbs of each of the 4 brands. Here we are using the data, and this data are really the created data here, and each of those data represents the lifetime of the electric bulb measured in hundreds of hours, that is in hundred hours. So this is one of the thing, and now our main concern here, can we infer that the mean lifetime of the 4 brands of electric bulbs are equal? So here we would like to check whether the mean lifetime of the 4 brands of electric bulbs are equal. So we would like to see these, whether the mean lifetimes are equal. So we would like to see this. Now, this is the problem. Currently, this is the problem with us. This is the main problem. And before starting the session, I would like to introduce in front of you the problem. So this is the brands, and this is 4 brands of the electric bulbs, and from each brand there are 3 electric bulbs, and this is the problem, that mean lifetime. So for this, I would like to start the session with the our example related to this, and we would like to refer our observation here. First, I would like to start from the very beginning of the session. This is called the analysis of variance, or the analysis of variance. So the basic ANOVA situation is all about 2 variables, one categorical, one quantitative. Main question here is that we would like to understand here, do the means, do the quantitative variables depend on which group given by the categorical variable? That means the individual is in. Here we would like to see basic thing, if the categorical variables has only 2 values. Now, if it is so, then 2 sample t-test, and ANOVA allows for 3 or more groups, because in the whiteboard observation we have shown, or the problem was that there were 4 such group: brand A, brand B, brand C, brand D. And now an example of ANOVA situation: subjects. 25 patients with blisters treatment, treatment A, treatment B, and these are the measures here, the placebo measurements of days until the blister heals. The data and the means given here: A 5, 6, 6, 7, 8, 9, 10, and B is with the values like 7, 7, 8, 9, 9, 10, 10, 1, 1. That is, and P 7, 9, 9, 10, 10, 10, 11, 12, 13. And these are some of the mean. Now, the question is, are these differences significant? We'd like to address, because considering our first example, in the first example, I was mentioning about the electric bulb manufacturing observation, and there were basically 4 brands, and 3 such bulbs were belonging to each of the 4 brands basically, and we were seeing the lifespan of those bulbs. So similar to that, we have taken this example also. Now, informal investigation. Now, for informal investigation, we can go by the graphical investigation, side-by-side box plots, and further, whether the difference between the groups are significant depends on the difference in the means and standard deviation of each group. That means, when I talk about whether the difference between the groups are significant depends on certain thing. The few essential component here would like to measure here. First of all, we would like to see that from the informal investigation, we can see like the observations like side by side box plots and multiple histogram. Now, whether the difference between the groups are significant depends on the difference in the mean, the standard deviations of each group. Now, with this, let me go back to my original whiteboard. There I used certain things for discussion, and I'm just turning the whiteboard here. 1 second, please. Give me 1 second. I would like to use the whiteboard again. Yeah, I'm going to use the whiteboard. Sharing my whiteboard here. Whiteboard has come. So first of all, I would like to see that in this given problem, our first priority is that can we infer that the mean lifetime of the 4 brands of electric bulbs are equal. We would like to see it, right? Now, for this, our basic step starts. We would like to see the null hypothesis here. We would like to set the null hypothesis is that the mean lifetime of the 4 brands of electric bulbs are equal. That means we would like to formulate the null hypothesis is in this fashion, is that we would like to tell that, or we would like to assume the null hypothesis here is that the mean lifetime of the 4 brands of electric bulbs are equal. So as a result of which, I am just, assuming it that H naught, colon mu1, mu2 is equal to mu3 equal to mu4. Now let x1 bar, comma, x2 bar, comma, x3 bar, comma, x4 bar. So here this denote the mean lifetime. This is the mean lifetime for the brand A. That is mean lifetime for the brand A. That is what will be the mean here. What will be the mean of these three values? Can anybody tell me, dear participants? Can anybody tell me from your side?
20.
Yes, exactly. So here the mean lifetime of the brand A will be X1 bar will be 20. Similarly, the mean from here, which we will be calculating as X2 bar, how much will be the value here?
23.
23. Very good. And from here, what will be the value?
20.
22. And from here, what will be the value?
21.
21. So these are what? These are basically, they are denoting the mean lifetime of brand A, B, C, D. So these are what? These are basically the mean lifetime of brands A, B, C, D. So these are the mean lifetime of the brands A, B, C, D. Now, we are basically also interested to take or carry forward this information. The information is that we would like to find out the grand mean. Grand mean, we would like to calculate here. First of all, let's go back. How many mean we have calculated here? How many means we have calculated? 1 mean, 2 mean, 3 mean, 4th mean. So 4 such means we have calculated. Now we would like to see the grand mean. In this grand mean, we have got X1 bar plus X2 bar plus X3 bar plus X4 bar divided by how many types of brands are available. There are 4 brands. 1, 2, 3, 4. 4 brands are available here. So as a result of which, we are also in a position to calculate the grand mean. So as a result of which, 20 plus 23 plus 22 plus 21 divided by 4. That means what? How much it will be? It will be 86 by 4. That means here it will be 21.5. Is that clear? Grand mean calculation? Hello?
Yes, sir.
Yeah. Now, our next step is that we want to find out the variance between samples. Variance between samples can be formulated or can be calculated. So first step is that our X bar information I do need. I do also need the information related to X double bar. And further, I do also need the information related to X bar minus X double bar. And further to these, I also need the information of X bar minus X double bar whole square. So these sort of informations basically I do need. And as a result of which, I was having with me the value of X bar, that is X1. Basically, we are talking about X, this is X1 bar, X2 bar, X3 bar, X4 bar. These are the values we need to have currently with us. That is 23, 22, then 21. Now, what is the value of X bar? That is the grand mean. It is same basically for all these 4 such observation: 21.5, 21.5, 21.5, 21.5. So these are the values currently we are having. Now, in this condition, we would like to also derive the difference here. That is the difference. Here the difference is minus 1.5. Then here is the plus 1.5 and then 0.05 and here is minus 0.5 plus 0.5 minus 0.5 and when I make it square it will be around 2.25 here also 2.25 and when I am making square of it 5 into 5 25 that is 0.25 here also 0.25. Now we would like to see the summation of x bar minus x bar bar whole square is equal to how much? It is 2.5, 2.25, 2.25, it will be 2.5, it will be our 4.5, then here 0.5. So ultimately it will become how much? 5.0, right? Hello? Hello?
Yes.
Hello, are you calculating? This will come around 5.0. Okay. Now,
Yes.
now, next step, we would like to also see the standard deviation here, standard deviation or the variance. We are interested to see the variance here. We are interested to see the variance here. Now, as we are going to calculate the variance or the, in this case, it will be summation of x bar minus x bar bar whole square divided by k minus 1. Now, what is this? This is basically how much we have calculated. This is we have calculated 5 upper part. And now what is k basically? Now, here it gives you the complete picture. Here, this actually represent the number of samples. How many samples are there? How many samples were there here? First sample, second sample, third sample, fourth sample. So ultimately, how many samples we took for the example here? How many samples we took? First sample, this is sample 1. This is about sample 2. This is about what? Sample 3. This is about what? Sample 4. So we took how many samples? We took here 4 samples and k is nothing but the number of samples, that is k is 4 minus 1. So 5/3 will be the variance here. Now we would like to also see the another interesting feature here. The another interesting feature is that we would also like to see the difference also here. That is, we would like to see the standard deviation here. Standard deviation, standard error, basically standard error. Standard error is nothing but this one, and we would like to see this one also. And for this, our the value that we are basically referring is equal to just a second, let me also okay. So we are here going to calculate this value as Sx bar is equal to square root of n into sigma x bar. Just I am transforming this part. I am just transforming. I'm keeping it here and just I am transforming it. And when I am making a square of it, and it will, take its, observation as this much. And n is how much? N is how much here? N is how much? What is the sample size?
4.
Each of, no. Sample size. These are 4 samples. First sample, second sample, third sample, fourth sample. And what is the size of the sample?
3.
3. Size of the sample is 3. So absolutely right. Size of the sample is 3. And multiplied by sigma x square. Now, it should be sorry. It should be sigma x square. It should be sigma x square. So sx square will be sx square. In this case, it will be equal to 3 into 5 by 3 because we have already calculated the variance here 5 by 3. So I put the value here, and exactly I am getting the response here, this much amount of the value as 5. Now, therefore, our observation from here, what we find that our first estimate of the population variance is basically based on the variance between the sample mean, and it's basically we have shown with this, and this is the basic variance that we are interested to find out. Now, what we are basically looking for? Now, we are basically looking for the variance within samples, the variance within the samples, variance within the sample. Earlier case, variance between the sample, it was variance between the sample. Now we would like to see the variance within the sample. That is, two things we can observe here. One is the variance between the samples and variance within the samples, variance between the sample, within the sample. So further to this, we would like to go ahead to calculate the observation for the variance within the samples, and we would like to compute, and for computation we are taking the brand A. Now, in the brand A, when we would like to compare it, we have got the observation as X, and further to that, we need to take the observation X minus X bar whole square. Now, currently from the data, we are having with us 20, 19, 21. This is referred to as X, and X bar is basically whatever we have calculated, like 20, 19, 21 divided by 3 is equal to 20. So our X bar was 20. Now, from this, what observation can I refer? X minus X bar, it will be 0, 0 square is 0. Then X minus X bar, X is what? X is currently 19. 19 minus 20 mane minus 1 square means 1. 21 means 21 minus 20 is equal to 1. 1 square means 1. So after that, we are having with us summation of X minus X bar whole square, and that is equal to the summation 0 plus 1 plus 1. It's basically 2. Is this calculation clear to all the participants? Esteemed participants?
Yes, sir.
Yeah. Further to this, we would like to check for the brand B. We would like to check for the brand B. So for brand B, we would like to have the observation as X. Another one is X minus X bar. This is the observation whole square, X minus X bar whole square. Now, currently, we are with the data for the X for brand B is 25, then 23, then 21. And as a result of this observation, I do have the observation for X bar, and it can be calculated as 25 plus 23 plus 21 divided by 3. And it will come around 23. And as a result of which, 25 minus 23, how much? 2 square will become 4. It will be 4 here. Now 23 minus 23, it will be 0 square means 0. 21 minus 23, it will be equal to minus 2. Minus 2 square means 4. And as a result of which, we have the summation of X minus X bar whole square is equal to 4 plus 4 will be equal to 8. Is that clear? Hello, hello.
Yes. Yes.
Okay,
Sir.
okay.
Yes, sir.
Next calculation, we would like to see for the brand C. In case of brand C, we do have our observation x and x minus x bar whole square. Now, in this condition, we have 24, then 20, 24, 20, 22. And here we have 4, 4, 0. Similar to that, we have also here the observation that we have earlier calculated, and summation of x minus x bar whole square is equal to 8. 4 plus 4 is equal to 8. Now, another for the brand D. In the brand D, what was the observation? X minus x bar whole square. So this is the case here. Now 23, 20, 20. And here the observation is x bar is equal to 21. And as a result of which we do have the variations like 23 minus 21 is 2, 2 square is 4, and again 20 minus 21 is minus 1 to the minus 1 square means 1, and 20 minus 21 minus 1 square means 1. And here we have the observation as x minus x bar whole square is equal to 6. 4 plus 1 plus 1 is equal to 6. Now, we are interested basically on the sample variance. Here it is the first sample, second sample, then we have got the third sample, fourth sample. We would like to see the sample variance. Now, for sample variance for the first case, in this case, I think some background noise is coming. I request to mute the background noise. Dr. Dipjyoti, kindly take the lead.
Dr. Shiv Kumar Kukan, kindly unmute yourself. Sir, you can continue now.
Okay. Yeah. Now, in this condition, I would like to find out the sample variance. I would like to find out the sample variance. And sample variance for the first case, it will be S1 square is equal to, and how do I write it? I write it summation of x minus x bar whole square divided by n minus 1. Now, what is our summation of x minus x bar here? X minus x bar is 2. And what is n here? N is basically the size of the sample. What is the size of the sample here? 1, 2, 3. That means size of the sample is 3. So 3 minus 1. So it will be 2 by 2 is equal to 1. So sample variance, the first one, for the first case, it is S1 square is equal to 1. Now, I would like to see the sample variance for the second case. Here also in the second case, we do have the summation of x minus x bar whole square, and it is divided by n minus 1. So it is basically summation of x minus x bar whole square is equal to 8, and n minus 1. What is n? 1, 2, 3. N minus 1, 1, 2, 3. 3 minus 1 is equal to 2. So 8 by 2 is equal to 4. So here it is 4 for the second case. Going to the third case. In the third case, we have the observation as that we would like to find out the sample variance here, and it is S3 square is equal to summation of the x minus x bar whole square divided by n minus 1. So x minus x bar whole square is equal to 8, and n minus 1 means 3 minus 1 is equal to 2 is equal to 4. So this case also I received 4. And in this scenario, what is the sample variance? S4 whole square. Now S4 whole square is equals to summation of x minus x bar whole square divided by n minus 1. So in this case, what is x minus x bar whole square is equal to 6 and n is 3 minus 1 2. That is equal. Hello, hello. Yeah, so it will be equal to 3. So in the first case I got 1, in the second case I got 4, in the third case I got 4, in the fourth case I got 3. Therefore, we would like to also calculate and would like to see the variance. Therefore, the pool variance here is basically the average. I would like to see S1 square plus S2 square plus S3 square plus S4 square divided by 4. That will be equal to 1 plus 4 plus 4 plus 3 divided by 4. And it all equals to 4 plus 4, 8 plus 3, 11 and 12 by 4 is equal to 3. And in this case, the second estimate of the population variance will be based on the sample and is basically given by this number. Now, therefore, we would like to find out the value of the f. That means f talks about the variance between samples. Variance between sample, I told at the very beginning, variance between the sample and variance within samples, variance within samples. Now variance between sample, variance between samples, we calculated variance between sample here, between sample, variance between sample is 5 and variance within sample we have calculated 3. So that means 5 by 3 is equal to 1.67. The value is 1.67. And basically, we would like to further refer the F table in the, in the book of any statistics for business, statistics for economics, or from internet. You can find the F table, and the table value we can calculate. Although in the manual calculation I do need the table value, but when I am referring it to Microsoft Excel, I am calculating with the help of the p value here. So for the f value, and at 5% significance level, 5% significance level, and degrees of freedom 3.8. Now why 3.8? Because 3 is coming from where and 8 is coming from where. Let's have a glance. 3.8. I told that 3.8. Now, what is that reason? How 3.8 has come? Now, you check here. You check here that how many such variables are here, how many such entries are there. Here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 minus 4, the total, there are how many samples? 4 samples. So 12 minus 4 is 8. Now, how comes 3? 3 is the how many number of samples are here? Samples are 1, 2, 3, 4. So 4 minus 1 is 3 and 12 minus 4 is 8. So that's how the 3.8 is coming here as a degrees of freedom. I repeat here. Here, how many number of samples are available? Here, the number of samples are available as 1, 2, 3, 4. Number of samples minus 1. 4 minus 1 is equal to 3. And how many such observations values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 minus how many brands or samples are there? 4. That means 12 minus 4 is equal to 8. So 3.8, based on that calculation, I do have the observation here that the value, the tabulated value of F for 5% significance level and degrees of freedom 38, the tabulated value, if we refer, we get the tabulated value as 4.07. Now, we are going to compare the calculated F value with the tabulated value of F. Now, as we are observing, the computed or the calculated value of F, which is less than the tabulated value, thereby null hypothesis is accepted. We are accepting the null hypothesis here. Therefore, we can say that the average, average lifetime, we go back to the original here, we can refer that the average or the mean lifetime of the 4 different brands of electric bulbs are equal because the null hypothesis was accepted. Is that clear, the calculation, dear participants? The calculations are clear?
Yes.
Yeah. Now, I will be going to the
Yes, sir,
theory.
yes, sir.
Yeah, I will be going now to the theory part, and prior to that, I am just using the Microsoft Excel just to recheck and to recalculate the observation here. Here, our observation was that we have accepted the null hypothesis. Now, let me keep this one with the observation, and I would like to open my Microsoft Excel here. Microsoft Excel, I'm going to refer the Microsoft Excel, and in the Microsoft Excel, I'm going to share my Excel here. Now, I would like to share my screen again. Now, in this screen, I do have the Microsoft Excel. I have opened it up. Yeah, I have opened my Microsoft Excel. And here, I would like to insert the observation. The observation is that I do have a brand here, set of brand. I have a set of brand here. And the brand speaks about A, then brand B, then brand C, then brand, sorry. I have written here brand. Yeah, and then we have the brand D. Now, initially, as I have thought of the calculation, that is 20, I do have 19 over here. Then I do have 21. These are hundreds of hours. The same thing which I have calculated manually. I would like to show you the calculation on Microsoft Excel. Here, further to this, I do have the observation like 24, then 20, and then 22. Further to this, I do have in case of D, that is 23, then 20, then further to 20. Now, it's all about the setting of my observation of all such values here. And I'd like to have a glance on these values. These are the 4 brands of electric bulbs, and these are the lifespan in, represented in hundreds of hours. So let me go to the data, and here the data analysis part, and there are so many techniques, ANOVA, single factor, 2 factor, with replication and without replication. Let me just go through the observations here. So here we would like to see the observation input range. We have got such inputs here. The input, we have given the input range here, and 5% level of significance. We would like to check the observation here. So to this, we have the observation here, average variance between the group and all this. I have the critical value of X. So here, the p value that is coming as 0.25, it is less than 0.50, and that's why we're accepting it. See, the calculated value of calculated value of f, it is coming as 1.66. Let me check what my this observation has given us. The observation that we actually observed to this, we have in our observation, this whiteboard is showing us something that if we can refer to our whiteboard calculation, f calculated was 1.67. 1.67. Now 1.67 we actually calculated by following the steps 1.67. Now what is happening when I am referring back to the Excel? Now Excel is showing me the observation as the Excel is showing me the observation of X. Yeah, f is calculated one is 1.66667, means 1.67. Now the critical value of f, we have seen the critical value of f was calculated as 4.067, matlab the tabulated value of f. Now here we would like to see what was the tabulated such a value of f. Basically we would like to see 4.07. Now let me go back and refer to let me go back and refer to this observation here in the Excel Microsoft. Yeah, 4.0706 matlab 07, and as a result of which we observe that the p value. Now p value is the decision criteria here. If it is less than 0.5, then in that case we accept. If it is greater than, then we reject it basically. And here we are accepting the null hypothesis. Further to this, as we are mentioning about the ANOVA observation, I'm just going to my slide is visible to all of you in the meantime. Hello.
No, sir.
Slide is not visible. I am coming back to the slide again. Here I am going back to the slide. 1 second, please. Yeah. Earlier slide was visible, Excel. Hello.
Yes.
Yes, sir.
Okay. Excel was visible to all of you. That's very nice. Yeah. Now I think slide is visible to all of you.
Yes, sir.
Yeah. Further, when we are going with the graphical type of observation here, so as I mentioned that the graphical type of observation, so far as we mentioned informal investigation for this, and we mentioned side by side box plot, multiple histogram, where the difference between groups are significant, depends on. We have calculated, we have shown a case study. On that case study, we referred about the 4 brands of electric bulbs, and under each brand there were 3 such observation, that is sample size was 3, and as a result of which the difference in the means, we observed the difference in the means. And further, the standard deviations of each group we calculated, and the sample size also. ANOVA determines p value from the f statistics. Now what does it do? At its simplest, ANOVA tests the following: the mean of all the groups are equal. Before starting the calculation, Dr. Dibjyoti, are you there?
Yes, sir.
Dibjyoti, I will just engage few more minutes if you permit me. Whether the other speaker is waiting.
They will join at 6:30.
6:30. So let me continue for few minutes, Dibjyoti.
Yes,
If
sir.
you permit. So here basically what happened is that, so since we basically calculated the different steps related to the basic first part of the calculation of ANOVA, we mentioned that all these steps. Now at the very beginning, we assume that means of those groups are equal. So see here, the means of all the groups are equal. Now, alternative hypothesis. Then generally we do not write the alternative hypothesis. Not all the means are equal. Doesn't say how or which ones differ. Can follow up multiple comparisons. We usually refer to the subpopulation as the group. when doing ANOVA. Assumptions in ANOVA. Each group is approximately normal. Check this by looking the histogram or normal quartile plots or use assumptions. Can handle some non-normality, but not severe outliers. Standard deviations of each groups are approximately equal. Rule of thumb ratio of largest to smallest must be less than 2:1. Normality check, we should check for normality using assumption about the populations. Histogram of for each group, normal quartile plot for each group. With such small data sets, there really isn't a really good way to check normality from data, but we make common assumption that physical measurement of people tend to be normally distributed. Now, here some of the examples being taken here at the treatment earlier case also. Here we use different the different notations, and all these notations I have used basically. And ANOVA measures two sorts of variations in the data, compares their relative sizes. Yeah, that is the main thing I have already told in the session, that the variation between group, one is within group, other is the between the groups. For each data value, look at the difference between its group mean and the overall mean. I called it when we referred, we calculated, we referred as grand mean. We referred as the grand mean, and where we can also call this as the overall mean, right? And further to that, a variation within the group, one is between the group, other is the within the group. And for each data value, we look at the difference between the value and the mean of its group, right? So how do we measure it? X bar minus X bar whole square. It should be double bar Xij minus Xi bar whole square. The ANOVA F statistics is a ratio between group variation divided by within the group, because we have already calculated, right? A large F evidence against H0, since it indicates there is more difference between groups than within groups. So here we can also use Minitab also. So there are some calculations between group, within the group also. So similar example I have already shown. These are the example Excel, because we have solved it through Excel. Also here also the Excel calculations we have plotted. So these are the few observations that I made basically. Sorry, I joined late actually, because there was traffic jam in between, so I couldn't reach on time. Sorry for this. Over to our colleague Dr. Deepjyoti Chaudhary.
Thank you, sir. Thank you. And it is not issue, sir. You reached late because we already glued to the system, because the earlier session was also going on. So there was
Thank you.
no issue. And it
Thank
was
you,
a
Dr. D.
wonderful discussion, sir. And it was looked like a classroom teaching by using this whiteboard and all. It was fantastic, sir.
Thank you, Dr. Deepjyoti. Actually, I actually limited the discussion on that theme point, because due to paucity of time, I couldn't explore the further option. So excuse me for that. And anyway,
Not an issue, sir. It was a wonderful expression on the whiteboard.
thank you all. Thank you for listening. And thank you, esteemed participants and esteemed colleagues. Thanks a lot.
I request quickly Vaishali ji to give the vote of thanks.
Yes, sir. On behalf of the organizing committee, I'm glad to be here to express my vote of thanks. I, Vaishali Chakraborty, session coordinator of 2-week faculty development program on research methodology and applied econometrics for social science, convey my special thanks to our resource person, Professor H. Ramananda Singh and Dr. Devamalya Ghosh, sir, for being here with us today. I would like to thank sir for sharing their valuable inputs. My special thanks to the convener, Dr. Dibjyoti sir, joint convener, Dr. Shravanti Mehti ma'am, and Dr. Taraknath Sahu sir. I would like to thank all the organizing committee of Vidyasagar University for the organizing such an informative program. I would also like to convey my thanks to all the backend coordinators who helped to make this session successful, and to all the participants of this FDP program. It was indeed a great learning session. With this, I would like to end here.
Thank you, madam. Thank you, sir. So wish you all the best. Good night.
So participants, we are again starting at 6:30.